Welcome to Net 125. My name is John Arkey and I will be your instructor for this semester. Pretty simple lecture today, relatively short compared to some of the ones that we'll see as we progress on. This particular class is all about preparing you for the first portion of the Cisco CCNA. This is going to introduce you to some basic networking concepts that we use in much more complex configurations as we move on. But we'll learn about how to do basic routing and how subnet masking works and things like that. So if you've ever been curious about how networks communicate with one another and keep everything separated in terms of data flows and whatever else, that is something we will definitely explore as we go through. But today, just a little introduction, just toes into the water. So let's get started. Chapter 1 starts out with talking about the global connection that networks provide us. We're going to talk about how we interact, learn, work, and play, how host devices can be used as clients, servers, or both, and what those terms mean. LANs, WANs, and the Internet is where we get into how network devices are used and what categories those devices may fall into. We'll talk about the devices and topologies of a LAN, or local area network, in comparison to the devices and topologies of a WAN, or wide area network, and there will be a couple of other network types we discuss later in the semester. We're going to look at the basic structure of the Internet, and I'm talking Crayola 8 color basic. We're not going into any kind of depth on that because that is a much more advanced class. And then we'll talk about how LANs and WANs interconnect to form the Internet as a whole. A term that I always heard used regarding the Internet that I have liked is the network of networks. And that's the idea, is that you have an inadvertent hierarchy that is formed because small network in your home is connected to your ISP. That ISP is connected to a larger network and a larger network and a larger network. And eventually there is no higher tier, if you will, and that is the basis of the Internet. The network is a platform. So the idea of it existing as a platform for being able to facilitate different activities is something that's really come into its own within the last 20 years or so. Versus when I was young, the Internet was a lot more niche. Now it's almost ubiquitous. Almost everybody has either an Internet, either an Internet presence or a need for the Internet to be present in their lives. We'll talk about a converged network, what that means, how we're incorporating different technologies and making the home more accessible from anywhere due to network introduction to various devices. We'll look at the 4 basic requirements of a reliable network, and reliability is a very important aspect of networks. And we're going to look at the changing network environment. And of course, you see that is the longest of the 4 sections for this chapter. We're going to talk about how new emergent trends, such as bringing your own device into a work environment, BYOD, instantaneous online collaboration through things like iWork and Google Drive, video and cloud computing, these are all changing how we interact, especially in the era of the novel coronavirus, COVID-19, excuse me. We have to exist in a much more isolated configuration, and this means that we rely more than ever on these infrastructures. We're going to look at how network technologies are changing the home environment even beyond the ways that I was just talking about, maybe not something as quote-unquote serious as working from home, but how do we make it easier to keep track of when we're running out of milk? We have smart fridges that allow us to have cameras. We have barcode scanners that we can use. We have all kinds of other items that we can keep ourselves connected with to a centralized database of some kind for ourselves, to allow us to keep an eye on what could make life a little easier. With emergent technology, however, comes greater threats. When you open a door, You know, there's just as much possibility that somebody could come in and try and steal your TV as just waving hello. You know, it's 50-50 shot. Now, that's not to say that people are endemically bad, not at all, but it's a risk. It's a possibility. All the stuff that your mom warned you about, right? But we're also going to say, hey, why would we curse the darkness? Let's light a candle instead. Let's find some solutions. And these solutions need to be applied at both the large and small scale. And then, of course, we'll talk about the importance of understanding the infrastructure of a network. A term brought up here is switching and routing. And something important to understand is that they are two different aspects of a similar process. And we'll talk about what those are as we go forward. So let's look at our global connection. Let's do our kumbaya moment, if you will. We don't have the conventional boundaries that used to exist when networks were first being established, the infrastructure that we so blithely rely upon today. We don't often think about that because we don't have to. If we sat in awe of all of the things around us in nature as well as in industry, I don't think we'd ever get anything done because we would just be agog at what is there. We don't think about the fact that we are able to pass information around the globe almost as quickly as if someone were standing in front of us. Now, that's not to say that there's not latency and there's not ways we could improve, but at present, we're actually doing a fairly good job of trying to eliminate borders as far as impediments to business, impediments to social interaction, impediments to knowledge. I mean, think about it. The video that I'm recording right now, once posted online, could be accessed by anyone. So the idea that somebody has to go to a special building and sit and listen to a lecture versus being a bit more self-taught, being guided by an outside influence, is a major result. The context in which we think about education, in which we think about work and how all these things will fit together is going to change dramatically, because now we realize that the need to go to a special location is going away. So how we learn, as I said, school has changed dramatically. How we communicate. Think about things like FaceTime. Think about teleconferencing, working in things like Zoom or Skype for Business. There's a ton of different video conferencing softwares that are out there. Working, of course, now means that if you want to present something very much like this, you can't just write the presentation. You have to figure out how you're going to package it. How are you going to put it together so that it can be accessed by the largest possible group of people? We have to think about the Americans with Disabilities Act, so the ADA, making sure that we provide for those who might be visually or auditorily impaired. There's all kinds of different items that we have to make sure are there, and tools like automatic generated text through Google or Microsoft rely on networks to be able to interpret the information that's in front of it and be able to give you intelligent results. So it's crazy to think that if we didn't have these networks, if we didn't have this intelligent design behind routing and switching and everything else, our world would be so much more limited. It wouldn't feel as if we were becoming part of a larger global community. So providing resources in a network means that we have to compartmentalize. And we have networks of various sizes. We have all kinds of things that pop up. So we have small office or home office networks, what we often call SOHOs. Medium to large networks, things that we would think about for, Cape Fear, for example, would be considered a medium to large network. UNCW, PPD, Verizon. Verizon would be a massive network. Possibly worldwide, depending on where all of their substations and things like that are listed. But again, there's a big difference in scale. If we think about the networks that are used by the U.S. military, in the various locations around the globe where they may have troops garrisoned or things of that nature, that is a massive set of network resources. And how do they all communicate? How do we make sure they're secure? All of these things will be revealed. Clients and servers. These are terms that we hear a lot, and it's important that we understand accurately what they mean. Clients request and display information. So clients are consumers. Servers provide information to other devices on the network. So they are providers. They're not necessarily generators, but they do answer those requests. So if a file client says, I need to request this specific document, the file server is programmed to be able to interpret that request, and if the permissions are correct, whatever other qualifiers you need, that information will then be made available to be accessed by the client. Maybe it will be accessed remotely, maybe it can be downloaded, it just depends. Different types of connectivity would be things like a peer-to-peer system. So client-server has a direct connection between two or more computers. Peer-to-peer means that we have a network that is formed of devices that are all sharing and consuming at the same time, so they can be both. So an advantage would be in that area that the network is a little bit more resilient. The more copies of a file that exist, if there are people sharing copies, the easier it is to bounce back in the event of a failure, if something collapses. But disadvantages mean there's no centralized authority. So if something goes wrong, it's harder to pin down the problem. And if there's a breach on one machine, then everybody gets put at risk. So we'll talk about that in more depth later on, but that is a crucial element of networking, is to discern the difference between peer-to-peer and client-server, and why in a particular instance you may wish to implement one versus the other. LANs, WANs, and the internet. Well, let's talk about components. Let's talk about the stuff that you're probably most familiar with, because it's stuff that you see all the time. End devices. These are what are at the end of each network. These are the little tendrils at the very end of the tree branch that are, maybe the base of a leaf, or maybe the leaf itself, things like that. Whatever you want the analogy to go to. But these are the sources or destinations of a message. So the examples here that I've got in this graphic on the right-hand side, handy little thing, would be something like a laptop, for example. Laptop has a web browser on it. Web browser is connected via the internet to a web server. That will go ahead and say, hey, I'm going to send an HTTP GET request to be able to pull the information necessary to view this web page. That information is relayed. The server interprets it and says, hey, I can go ahead and process that for you. I'll send it back. So the source of the request is the laptop in this instance. Once the request goes through, however, the transmission, the receipt of that information means that it becomes a destination. So things can have multiple roles, even if not necessarily they're in a peer-to-peer situation. It's just, is it doing it in turn, or is it doing it simultaneously? That's usually the defining characteristic. Now, intermediary network devices connect multiple networks together to form an internetwork. So what we're looking at here is probably most of the second row of the graphic on your right. Switch, router, and multi-layer switch. Hubs are a little bit different simply because they work internally, very much like a switch does, but it is part of the structure. Firewalls, of course, prevent information from getting through without being passed through the proper channels. Wireless access points and routers, these of course provide wireless connectivity to non-cabled devices. And what these all do, these connectivity devices, is to provide consistency and predictability in the data flows that are generated from one device to the next. So we provide connectivity, we provide predictability, and we provide security in certain cases. Though security is more the work of policy and of the people using the devices than it is of the devices intrinsically. So how do we connect these devices together? Well, we use what we call network media. Media is plural of the word medium. So a medium You know, sometimes you'll think about not just like the t-shirt size, but when you hear about like somebody who claims to be a medium, they're usually claiming to be like a psychic or something. And what that means is that they are a vehicle to transmit information from what one would perceive as being a supernatural realm or you know, extra normal to people into an environment that could be used by more common perception. You could also think of it as like a translator. Okay, so we hear that term. News media, you know, that term means that they are a vehicle of conveyance. They are also a vehicle of interpretation, as is so often brought up, that, you know, different news agencies have their own spin that they put on things. They have an agenda. Well, network media is not much different. The idea is that it conveys information from place to place. It provides the pathway for data transmission. It connects devices together, provides a predictable path on which they can transmit their contents. The different types of media have different qualities, different properties. So copper, for example, is very reliable. You know, it's easy to put in, very flexible. Problem is that electrical impulses being transmitted very close to one another have some interactions, what we call interference. They also lose signal over a certain distance. The signal cannot propagate itself without a repeater. That's called attenuation. So we run into some distance issues there without having to insert extra components. Fiber optic. This helps to get rid of some of the distance stuff. Significantly longer distances can be supported because it doesn't use electricity. It uses light pulses. But fabricating these fiber optic cables is a lot more complicated. The cables are not quite as resilient in terms of being able to be bent or twisted. And running something in duplex, meaning that we're sending in two directions at the same time, requires two cables as opposed to just one cable, which we would see with copper. And then wireless is going to be, we don't want any cables at all. We want to just, you know, have things going directly through the air by means of radio frequency transmissions. Now, in certain areas, there may be lots of radio frequency signals that cause a lot of interference, or you may have an area where maybe the walls, the infrastructure, those signals can't penetrate. They get you know, diffracted, basically broken up into several smaller streams, and you lose data in that capacity. These also have a range limitation, pretty significant in certain cases. Depends on what type of wireless transmitter you use. Some can be what's called a collimated transmitter, which can cover a very long distance indeed. So it just depends. But in general, there are plus and minus qualities for each of these three primary types of media, and we have to, as technicians, be able to assess those benefits and detriments to be able to give a client the best recommendation for their needs. And you know, there's advocates that I've dealt with out there that are like, oh, everything should be fiber optic, and I'd be like, well, yeah, that would be super fast. And most of the backbones of what we use is fiber optic. We haven't really laid new copper down since the 80s, but putting fiber into people's homes becomes problematic, you know, overhauling all that infrastructure, things like that. But as time goes on, you know, of course, the infrastructure will change, and we will make updates just a couple of pieces at a time. So these are just some representations. These are some symbols. We see here in the top right, that's very clearly a laptop. Next row down on the left, that is a desktop. We get down to the very bottom row on the left that looks kind of like a TV. In the middle, there's a phone, but it's got the letters IP on it, Internet Protocol. So that indicates that this is a non-landline based phone in the conventional sense. It's not hooked up to a quote-unquote phone line, Cat3, and instead would be connected to an internet device, which would route it instead of a local telephone exchange. And then a printer on the right. Above those three devices, we see these wavy lines, looks kind of like DNA. That's supposed to represent a wireless network, things like that. And then the last one, which is one that you'll see quite a bit in this course, especially when you start playing with Packet Tracer, is the router. Now, the router is a little bit different than the switch. The switch is very similar in that it is a standard polygonal shape. Instead of a cylinder, it would just be a rectangular prism. I wouldn't say a cube, because a cube is equal on all sides. But a router, you see that it has two arrows coming in towards the center and two going away, whereas the switch would only have an arrow going to the left or to the right or up or down, depending on the orientation. That's because switches deal with internal traffic only. They don't have the ability to communicate across networks. They have the ability to communicate between devices on one network. A router, on the other hand, has the ability to say, okay, I'll handle stuff going from an internal source to an external source, etc. These diagrams are important because we have to look at topologies. Topology is just a fancy way of saying layout or arrangement. Now, we have layouts and arrangements that we can look at in two primary ways: physical topology and logical topology. The physical topology of a network is the bird's eye view. If we walk into a room and we take a look at where the computers are laid out and things of that nature, how do we perceive that? You know, if we have a desk at the front of the room where the teacher sits, and then we have several subset desks heading back, those are all positioned physically in space. If we look at it logically, however, is there a difference between the position in the network of the instructor's desk versus his student's desk? Excuse me. Maybe. Unlikely, however. Most of the time, you have what's called an MDF, a main distribution frame, which is your primary connection point from your ISP, your internet service provider. And that, if necessary, will connect to an IDF, an intermediary distribution frame. The distribution frame essentially sends out all of the secondary lines from the main one to branch off to maybe an office has its own internal switch, and then every device in that office connects to the switch. So maybe there's like 5 computers, a printer, and a smart thermostat. Those things may all connect to that switch. That switch then feeds the information back to the MDF, or maybe to another switch first, and allows that information to be funneled into narrower and narrower constraints until it reaches the MDF. The MDF can then transmit it back to the ISP and be able to process information that may come from outside that particular building. At that point, we're looking at it logically. So logically, I tend to recommend you think about it very much like a family tree. You know, you have a series of people on a particular row that represent a generation, you know, people who would be considered cousins or siblings. And then above them would be aunts, uncles, parents, things like that. And then you go above that, and that would usually be grandparents, great uncles. So we have a hierarchy, we have layers. Physical topology stuff can be all over the place. You know, you could theoretically have a laptop that's bolted to the ceiling for some strange reason, and it doesn't matter versus a computer sitting on a desk in terms of how the network sees it. It's just one more device on a particular interconnected or intermediary device. So here we have a local area network diagram on the right. Kind of what I was talking about a moment ago. On the far right, we see what's supposed to be a server. In the middle, we see a switch. You can see that the arrows, again, a little bit different than a router. Instead of pointing inwards and outwards, they just point left to right. So we have, you know, 4 devices here. We have a phone. We have 2 desktops with people sitting at them. There may be another desktop that's supposed to be some kind of, you know, access terminal for an inventory system. Who knows? Maybe it's in the warehouse. Anyway, the idea is this is covering a relatively small geographic area. You know, it could be a single office building. It could be, you know, a 2-bedroom apartment. You never know. But these end devices are tethered together to a central point. Eventually, there's, you know, a small group of here, small group over here, and then that small group is connected to this small group, and it comes to a primary point of connection. These networks are administrated by a single organization, meaning there's one set of individuals, or maybe just one, who are responsible for setting up the network, making sure it functions correctly, and if anything goes wrong, going in and fixing it. WAN, wide area networks, interconnect LANs. So very much as devices are grouped together to make a LAN, LANs can be grouped together to create a WAN. This can be administrated by multiple service providers and administrations. And traditionally, the links between the LANs will be slightly slower, but they will have more, it's weird because they'll have more bandwidth in terms of being able to carry more material at once, but the individual speeds for each one will be slightly slower. So internally, everything will seem to be kind of snappy and move quickly, but it's not going to be significantly faster moving outside of that network because it's carrying a lot more capacity. The internet, as I said at the top of our lecture here, is the network of networks. And you can see there are several different lands here: home lands, government lands, school lands, all that stuff. And they're all connected. So we go from a router at an individual location to a multi-layer router. We can see here these different control devices in the middle, and that they're all connecting to each other. And this is a hyper-simplified method of looking at it, but the idea is very clear. There's no group above these central switch boxes that is controlling any group, right? So the idea is that no one individual or no small group controls the internet. The internet is controlled usually by the telecom authority for a particular country in that geographical area. And then those geographical overlaps, they're regulatory. They're not controlling. They're just saying, okay, this is the standard level of operation. But of course, people like to deviate outside the rules. So it's kind of a loose co-op rather than it being any form of superior or inferior hierarchy. There are also some different types of nets that you may hear about that exist within the internet. The internet, of course, covers the entire world. But for a company, there may be some internal and external sites that they wish to maintain that still have a level of privacy. Intranet would mean internal company consumption only. So in the case of CFCC, there are some HR forms and things like that that I can access through the CFCC intranet that will make it easier for me to do my job as opposed to having to tromp down to the cashier's office or registrar's office or records or HR and fill things out on paper and hand them in. We can automate this process. We can do all these forms online, and it's much faster. It's the same level of security because there's digital signatures and things like that to make sure that I am who I say I am, and the place where I'm submitting it is in fact legitimate. But then, what if I were not a faculty member here on campus? What if I was a contractor? I was being brought in for training. Let's say that there's some new platform that the school buys because of the online switch that we're doing, and they need access to certain CFCC materials in order to access buildings, fill out a form to get a key for a particular room, whatever. That would be supplies to a collaborative individual, but not internal to the company. And that's where they would be involved with what's called the extranet. An extranet is stuff that you want to have available for people who are affiliated with your company, but not directly affiliated. You still want to have a measure of security because it's not public information, but it's also not something that we need to keep under absolute lock and key. So you can think of it as, public, private, confidential, whatever characteristics you want it to be, to where, there's stuff that you share with the world, there's stuff that you share with your friends, and there's stuff that you share with your family, or if you're married, if you have a spouse, or if you have a child. There are certain types of relationships where there's a higher level of trust, if you will. So intranet, in this case, would be probably the highest level of trust. Extranet would be a bit more moderate, and then the internet would be public. Everything is shared. So we've talked about a couple of different things for these technologies before. We talked about the concept of the ISP, the Internet Service Provider. That's just a company that facilitates the higher level aspects of communicating with larger and larger WANs. Broadband cable, that's part of our media that we talked about. The concept of broadband means that multiple services are carried on the same network link. Broadband digital subscriber line, or DSL, that was one of the first high-speed internet connections that were made possible using the telephone infrastructure that was already present. So you may have heard of ISDN as well. These used different types of filters and traps to block out certain frequency bands to try and transmit information more aggressively than the standard 56K dial-up modems that we were used to using. Wireless WANs, there are wireless area networks that are almost entirely wireless, cover very large areas. If you look up the technology WiMAX, which I believe we will talk about later on in the semester, you'll see more of what I mean. Cell phone networks are considered to be wireless WANs as well. Mobile services, so there's a number of different mobile services that are around, specifically like cell phone networks. That's probably one of the big ones. Business DSL, there's a big difference between business DSL and consumer because businesses often need to upload information just as much as they need to download it, be able to provide things and access for customers. So DSL was interesting in that they changed the filter bands to say, okay, 20% of your network connection will be for upload, 80% will be for download. So that means that if you had, 100 megabits total, let's go crazy and say that was, cable equivalent, that you could download 80 megabits per second. Now that's 10 megabytes because there's 8 bits in a byte. But you also had 20 megabits per second that were reserved for upload. So if you wanted to post something to YouTube or anything like that, which would be about 2.5 megabytes per second. So there's a big imbalance in the upload versus download speeds. With business DSL, they may say, well, we need something closer to 40/60 or maybe even 50/50, depends on what type of business they are running. So they would need to discuss with their provider and say, okay, we need symmetrical DSL, meaning that the upload and download speeds are equivalent, whereas ADSL is much more common. Leased lines, that's part of the whole DSL thing. That's just another term for it. Metro Ethernet is being able to use Ethernet connections based on almost like a public utility. Think about going downtown and certain businesses have free Wi-Fi or things like that. Imagine if that instead it was a hard line. So any building you went into, kind of like being able to plug in your phone charger in the airport, if you were to just plug a hard line into the wall, you would be able to connect to a network source. Internet connection types, we talked about this a little bit earlier with the SOHO, small office, home office. There are also, of course, business connections. Business connections tend to be more expensive per month because there are significantly more users involved. A home network probably has less than 10 individuals using devices at once. Now, that's not to say that you wouldn't have one individual maybe using a smart TV that is connected, a smart thermostat, a smartphone, and they're also playing music over an iPad connected to a Bluetooth speaker or something like that. So you could have one person maybe using 3 or 4 devices at once. But again, like the number of connections, the bandwidth demands are very different. Whereas a business probably is going to be a lot more aggressive in terms of its requirements. So that's why, if you hear about, Spectrum has a business class connection that they offer that is much, much faster. But again, much more expensive because you are taking up more space in the queue. The network as a platform. So when we talk about a network that serves multiple technologies simultaneously on the same infrastructure, that's what's called a converged network. So this is where we're able to transmit data, just text, being able to send block messages or things like that. And then telephony, meaning that we can support either IP-based or just standard telephone line-based telecommunications, full duplex. And then multimedia, being able to send things like audio, video, whatever else, beyond just binary data. So this is data that we consider to be structured. So that's why we list data and multimedia on different lines. So convergence is the idea that we move all of these different services into one architecture, so that way we don't have to have a computer network and a phone network and a multimedia network or things like that. We can have all of this run on the same general connections. We can use the same lines, we can use the same hardware. So when we're building a network, we have to pay attention to 4 unique basic characteristics. Fault tolerance, which is the ability of a system to bounce back in the event of a failure. Scalability, which means the ability of the network to grow or shrink relative to the business's needs, or the network's needs, excuse me. Quality of service, meaning that can we prioritize traffic? Can we say that this particular computer gets a higher level of priority whenever traffic is ramping up and there's a lot of usage, versus say a smart thermostat. A smart thermostat may only need a couple of pings here and there, but we want to make sure that that priority is fairly low, because you can wait a second to know what temperature it is, but being able to upload an important file or maintain video conferencing, that needs to be prioritized. So that's part of the whole quality of service thing. That's an easy way to kind of get you introduced to that. And then lastly, but certainly not least, we have entire courses and even degrees, master's and PhD programs on network security, cybersecurity in general. We've just added our cybersecurity major within the last year, and it's been a great success so far. So if you guys are part of that platform, thank you for helping to build it with us. But the idea is that we want to make sure that the other three items that we talked about in a reliable network and the data that's being transmitted are not being kneecapped, essentially, by a lack of secure presentation. So some vocabulary I want you guys to know. And I talked about this a little bit ago, the idea of bandwidth being that multiple frequency bands, the amount of information. This is a theoretical capacity, meaning that if everything is working exactly as it's supposed to, this is the maximum amount that we should be able to move from one place to another. Generally, however, what we actually get is called throughput. This is the data that actually makes it from one side to another. Now, this doesn't necessarily mean that the data that is sent or that is actually received is necessarily good. It may be that a ton of data gets sent, but because of attenuation or a damaged cable or software corruption or things like that, there may be loss of that data. There may be data that is unusable. If that is the case, we have to filter out that information and look at what is actually received that was useful, which means that we go from bandwidth, capacity 1, we narrow that down to throughput, what we actually receive, and we narrow that down again to good put, meaning that that's what we can actually use of what was sent. So congestion occurs whenever a network's traffic begins exceeding optimal capacity. Network congestion is when things just basically start getting bogged down. There's too much going on and the system can't keep up. So in order to fix that, we incorporate something called flow control. Flow control is a dynamic response to traffic issues based on basically what's called an acknowledgement number and a sequence number that adjusts what's called a sliding window. So in the right-hand side, you see a graphic of these different boxes going from right to left. And what they do is they say, okay, we've got a 2 kilobyte block, sequence 0. Now in a kilobyte, there is 1024 bytes. That's what kilo means, is 10 to the third, but the closest thing we can represent in binary, again, something we'll get into later in the semester, is 1024. So 2 kilobytes would be 2048. So the new sequence number, the new acknowledgement number, must become 2048 when we say we've got it. So sequence 0, sending 2K. We're going to acknowledge that we have 2K. We're going to say that the window is 2K and send that back. Now the device says, okay, well, you got the first 2K clearly. We're going to go ahead and change the sequence number and send another 2K. The window is now going to be 0. It's going to go ahead and say, I acknowledge now I have 4096. I'm going to set my window to 2048 again and send a secondary acknowledgement. So we see the sender application's having some issues at that point. It has to send 2 acknowledgements because the first one says window 0, meaning that like I'm blocking up. Something's going wrong. It's like, okay, now I've caught up. Let me send it again. And then they're saying, okay, now because we have these double acknowledgement problems, I'm going to cut it down to 1K instead, starting at sequence 4096 now that we've acknowledged what we have. So the next one, of course, will be 1024 above that. So that would be, I believe it's, lost my ability to do math for a second, 5,120. And then it will go ahead and bounce back. And if eventually the receiver is able to handle a larger amount of information, it will then slowly ramp back up. Basically, the acknowledgements will come through and it'll occasionally do like a little test ping to say, hey, can you handle something larger? If it can, it'll move up. If not, it'll stay where it is. And if it has any further problems, it'll move down and move down and move down. That's why whenever a network's website is getting congested, there's a lot of flood traffic, things like that. Maybe this happened a lot on Facebook actually a couple of years ago. George Takei played Mr. Sulu on Star Trek, of course, very well-known actor in the annals of sci-fi. Really generally nice guy from what I can tell. Of course, you can only tell so much from public persona. But he had this thing where he would go through, he and his husband Brad would just find stuff online that he found amusing and would post it to his personal Facebook page. And people would just flood those sites because he had a huge amount of reach, huge amount of influence. So when that happened, websites would get drowned in traffic and wouldn't be able to keep up. So we would probably see a lot of this kind of constriction on the traffic that was being generated. We'd have information going in. It's like, oh yeah, everything's fine. And then all of a sudden it's like, oh, I'm used to only seeing a couple hundred people a day. Now I'm seeing a couple hundred people every few minutes, and my bandwidth gets choked down. Last section for the day, the changing network environment. Okay. So there's a lot of trends that are out there. BYOD, online collaboration, video communications, cloud computing. A lot of buzzwordy sounding stuff. But what does it all mean? Well, bring your own device is the concept that means you can use your personal cell phone for business and personal information. This is going to reduce liability for a company to say, I need you to have a phone for work, but if I require you to have a phone for work, I'm going to have to pay for it. That's just, that's the accepted logic. So that decreases that liability financially. But the cost is going to be reinvested a little bit by saying that IT now has to be able to support these devices, which means that for BYOD purposes, if we're going to reimburse, we need your device to be compliant by being part of this particular family. Like we can't use any Android devices that are more than 5 years old, let's say. We can't use any iPhone devices that are more than 3 years old, something like that. Now, this is as of, I believe, 2014, the graphic on the right. 38% of U.S. CIOs, Chief Information Officers, were expected to support BYOD by the end of 2012. So we're sitting 8 years later. I would be surprised if that number was any less than double what it's currently listed. So 76%. I would say that if businesses in the U.S. that were calculated for this list are now at less than 75%, something is seriously up, because BYOD has been around for a while. It has been proven to be very useful and psychologically very satisfying for customers because they don't have to tote around a bunch of extra stuff. In 2013, 82% of surveyed companies would allow some or all workers to use employee-owned devices. So that's a pretty massive number. And what I'm saying is part of why I said 76% just a moment ago is because I feel like these two numbers have probably shifted. Very few companies are now like, we want to be responsible for paying for a device and quote unquote owning a device that is constantly out of our control, out of our hands. So now there's a lot more just like, okay, you go ahead and get this particular product or device and we will reimburse you for a portion. You just submit it. That way the major onus of paying for the phone, maintaining the phone, things like that is on the user, and then reimbursement comes later. So there's still an investment. Companies are still responsible for that, but people maybe get phones that are slightly better quality or more complex, maybe more robust in terms of battery life or internal storage than they normally would because the company is helping out with the bill. So helps to kind of drive the cell phone movement forward a little bit further, helps to improve iterations of new devices. Cloud computing. This is the idea that we distribute the workload that we would normally do on a local machine and send it off to a remote site. Access to things like data processing, any kind of hardware acceleration, rendering for 3D graphics or items like that, compiling code. When I was first learning how to program iPhone apps, when I was first learning Objective-C, there was no IDE, Integrated Development Environment, for Windows for developing Apple iPhone applications. You had to have a Mac. So what you could do instead was actually write your code in the raw, essentially, in like a text editor, and then use what was called Amazon Web Services to be able to upload your file. They would compile it on their hardware because they had Mac hardware that would compile it, and then they would send you back your compiled application. Now, this isn't very conducive to what I first learned from Mr. Jeanette. Some of you guys have him. I think he's an awesome instructor. What's called RAD, Rapid Application Development. So in rapid application development, if you're doing something like Visual Basic, or if you're working with Eclipse, or with pretty much any other compiler, like idle if you use Python, you type in your info, you hit compile, flashes up, does whatever it needs to do. And it's able to give you error messages on the fly and things like that. This was not something you were able to do. Eventually now, of course, they have Objective-C plugins for, I believe Visual Studio now has iPhone app development support and things like that. So it's important to be aware that just because something isn't immediately present doesn't mean that it's not possible. And being able to reduce, instead of me having to go out and buy a Mac, I was able to use a web service that I paid, golly, I think it was like $4 to $6 a month. I was able to get through that semester of learning how to program those applications. It was just a little bit more labor intensive as far as waiting to get things done and sending things back, but it made me a better programmer because I had to focus on my logic a lot more. I had to make sure that I was staying on top of not being lazy and letting the IDE do all the work for me. So the physical proximity wasn't necessary, but the information was still being sent off. Cloud storage, being able to send information and save it somewhere. You can't actually see data on your hard drive in your computer. You can't look at the, number one, it's in a sealed container, but if you were to actually open up the hard disk, number one, it would be ruined, but number two, you couldn't really see, oh, there's my Word document over there in that corner. Like, that's not how that works. So it's very, very different physically, but not very different logically. The information is just kind of poof out there in the ether, and with the speeds of internet connections now and things like that, as long as you have a steady connection, cloud computing is no different than emailing your friend a file. It's just automatically storing things in a remote location or backing them up. Maybe it's just creating a duplicate. So don't be afraid of the cloud. It is here to stay. There are lots of awesome things about the cloud that help to make companies who would otherwise have to make thousands of dollars of investments, or sometimes even tens of thousands or hundreds of thousands of dollars. Instead, you can just rent it. It's kind of like going and buying a van versus just renting a U-Haul. Think about it that way. Technologies for the home. Of course, we talked about this a couple of different points today, but the idea of the smart home, being able to provide network connectivity for a number of different devices that we wouldn't necessarily think of. The TV, of course, we think of quite a lot. Game consoles, your phone, home computers, very simple. But what if you have something like a solar panel and you want to check your output? Having a little sensor attached to that will allow you to view it from a remote network device that's on the same network connectivity or same credentials. You can also have your smart thermostat. You can have a smart fridge. You can have a smart washer and dryer. You can have a smart coffee maker that you can control remotely. And there's lots of automation that doesn't even require a direct interface of a specific device. I've seen an egg tray that basically just has a pressure sensor in the bottom. You come home from the grocery store, you put your eggs from the carton into this little tray. It sits in your fridge, and the pressure sensor is tripped whenever somebody has an egg or similar item in the tray, so it can count how many eggs are there. If you put in a dozen eggs, and as you use them, if you set up a little alert to say, when this container is less than half full, send me a text message. And it will go ahead and pre-program that and get all the info, and it's just like, boom, you need to pick up some eggs. Power line networking. There's two properties of this. There's power line networking and power over Ethernet. Power line networking basically says we're going to use the existing power lines that are in your home to connect devices. And this requires that you have injectors and filters to be able to separate those data signals. But again, if you have electricity, you can then have network connection without having to run a second line. Wireless broadband, we have what are called WISPs, Wireless Internet Service Provider. WISPs is always fun to say because, I guess just the way I speak, but it's just that sounds like I'm trying to call my cat. This is a wireless broadband service using cellular technology. So instead of having an ISP where we have to run hard lines for everything, we can instead have a wireless service that is able to connect to all of our devices. And what it does is just look for whether or not we are authorized on a particular device. So imagine treating everything in your home like it was any smart devices anyway, like they were a cell phone. So imagine that your TV has a cell phone identifier, your laptop, your game console, your fridge, any of those things. So instead of it being connected via a hard line or being connected via a local Wi-Fi system to where you have a router with a Wi-Fi access point on it in your house, you would instead just connect directly to your wireless ISP. So strange times, man, if you think about it. Moving further and further away from the idea of having to tether something with a physical cable to get it connected to a network. But as I said at the beginning, the more connectivity we have, the more possible entrances we have, the more dangerous it can be because we have these external threats. The more information that we make wirelessly available, then we have more situations where a potential threat can get in. And once a potential threat is in, they're able to get a hold of all of this different information. They're able to, possibly mess with stuff. They could crank your thermostat up to 85 degrees in the middle of the summer, and try and, make all your houseplants die, or remotely mess with your fridge so that it just floods your phone with a series of ping messages just to be annoying. Or maybe it's spying on you through your TV. There's a ton of different things of various levels of potential annoyance or danger, but those compromising infections or intrusions are still real. And I tend to look at it this way. No intrusion is greater or lesser than another. An intrusion is an intrusion, and it's no good. So we need to make sure that although the potential results can, of course, be worse, the intrusion itself is what it is. It's a problem that needs to be addressed, and it needs to be treated seriously. Because if you can get in through a small hole, eventually you can worm that hole larger and larger and larger, and then it becomes, just a Mack truck of potentially compromised data, plowing through your house. So things like viruses, worms, Trojan horses, spyware, adware, there's all these different buzzwords. I'm not going to just list all these things off verbally to you I'm not going to insult your intelligence. But the idea is these are just categories. Very, 7 very simple groups of things that could happen. So be aware that, having a smart home and having all these different connected devices and being able to synergize your life by saying that, I can be sitting in my living room and I can tell Alexa to go ahead and dim the lights and, adjust the thermostat and things like that. Especially think about, I remember when I was still an undergrad and I was single, living in my own, I had a little 2-bedroom apartment, and I got a kind of a fluish attack at one point, and I was just absolutely just lagged out, right? So how nice would it have been to go ahead and go to the kitchen, get myself, big glass of water or whatever else, lay down on the couch and be able to tell my television, go ahead and put on Netflix, load up Mythbusters, dim the lights, go ahead and set the AC to this without having to move. Because, the muscle aches are always horrible whenever you feel sick. So it's crazy. Imagine being able to do that so effortlessly. And there's so many different pieces of software out there, because now there's jockeying for competition for being able to provide the most effective methodologies for connecting your home to different automation systems. But if you just set all these automation systems up and you don't understand that there needs to be a strong level of security behind them, you're going to find yourself in a real spot of bother. So again, like I said at the top, why curse the darkness when we could light a candle? Preparation is the big one. Being able to say, hey, we're going to use structured methodology to say, I'm going to create these connections. I'm going to take responsibility for these connections. And I'm going to find ways to make sure that my information and my resources are not being co-opted or compromised in a way that I did not authorize. And that's the biggest thing in security, is just saying, okay, I'm going to establish this connection. How do I make sure this connection is as safe as it can reasonably assumed it will be? You know, what is the reasonable assumption for setting this up? So antivirus and anti-spyware, anti-malware, all that stuff is super elementary, super basic. If you don't have a comprehensive anti-malware or antivirus program on your machine right now, keep it updated and run regular automated scans, you are going to be in a world of hurt, because there are threats that come out every day that will potentially compromise things. And once you've got one, it just starts weakening the foundation, and then there's another one and another one and another one. So it is a difficult game to keep up on. You're tap dancing on quicksand, but you have to do it if you're going to be connected to the network of life, as it will. You have to make sure that you've got things to keep you safe. Firewall filtering. This is a little bit more advanced, but for the majority, your operating system will kind of do it for you. Windows definitely will. Dedicated firewall systems. This is a lot more aggressive. This is having a specific standalone hardware device that acts as a separate firewall to prevent possible intrusions. And the benefit here is that if something is giving the firewall an issue, if it gets through the firewall, there's still possibilities that your antivirus, software, firewall, all that stuff on your local machine may prevent the attack. And in certain cases, if your firewall knows that it's been penetrated by outside hardware, it will shut itself off. And if it's the connection between your PC and your modem, then nothing new can get in, which means that you can then go ahead and go fix the problem before you reopen it to the internet. So hardware-based firewall systems are very, very useful. When you get into later classes, especially if you get into like Net 225, things like that, you talk about UTMs, and you talk about 126 as well, but these machines that essentially are built to handle all of this for you, they deal with what's called IPS and IDS, which is intrusion prevention and intrusion detection, to go ahead and prevent things from being able to breach your local network. ACL, Access Control List. This is basically just a permissions list saying that who has access to what. VPNs, virtual private networks, these are ways in which people can work from home and still have a connection that is considered to be secured. It relies on something called tunneling for the most part, which is hiding a packet within another packet, usually an IPv6 packet within an IPv4 packet, which is authenticated when it reaches its destination, and the data cannot be interfered with really until it reaches the other side. So what does all this mean for us? Now, Cisco just happens to be the sponsor for this type of technology, the course that we're teaching for that certification, the CCNA. Cisco Certified Networking Associate is a good first step. Eventually you move up to the networking professional, networking expert, networking architect. You can make a whole lifetime out of getting better and better and better and understanding how these things work. The idea is that with Cisco, at least, you find a way to ensure connectivity over any combination of networks. We can put this hardware together in tons of different configurations, and if you understand the basics, the hardware is not going to make your life more difficult by refusing to communicate. We can have that consistent operation. That said, as much as I love Cisco, and I've worked with Cisco pretty much all of my adult career, I still do a lot of work with open source. So if you have not done so, familiarize yourself with things like Ubiquiti, and there's a ton of different companies out there for various types of hardware. And there are things that are licensed, things that use a lot of money to make sure that your devices work to the pinnacle of what they should be. Companies like Aerohive, which are considered, pretty good mid-grade, high-end systems, things like that. So just be aware, there's not just one out there, but being strongly familiar with one that is so pervasive and it's everywhere is a good start. Okay. So that is our chapter. So thank you very much for your time and attention. and we will get back together next time for Chapter 2.